Hello, everyone. Thank you, Trisha, Michael, and Ramesh for the invitation to deliver a keynote for this important event, NADA Agentic AI Web Summit. I believe that we have a decade of the agentic AI. 2025 is the genesis for the agentic AI economy to play out. We are, I think, have at least a decade to build upon it. But we need the plumbing, like Professor Ramesh Rasker has mentioned in his recent LinkedIn post, which I resonate very well. You have the A2A as a load, and you have the NADA index as phone book, and there's another whole project is trying to build the city of the agent. And eventually, we currently building the foundations. And in this keynote, I will talk about some of the security foundation that our OWASP project is doing, and also some foundation framework that NADA is doing in terms of performance, in terms of the marketplace, the economy, in terms of the decentralized identity, the decentralized trust, especially the advanced AI security that Michael and Tricia are leading. I think it's very good collectives to build the agent AI web together. Uh, as everyone knows that we do have the bigger player in the market as well. Those frontier model builders, they will also play significant role, but this is not just them, it's everyone. We certainly need to have the voice of the community to talk about and to build also the agentic AI, which has the security and the trust built in. So I will have a few minutes. I will just share the PowerPoint for a few minutes about the work we are doing, and then we can, uh, yeah, to start. Okay, so I will start with sharing. First of all, myself, I'm a AI researcher and also book author. I wrote many books. Some of the book I listed here, but my book is mostly cover the blockchain Web3 security and agentic AI and generative AI security. My book has been published by 6 different publishers I listed here. I co-chair two Cloud Security Alliance AI Safety Working Group. One is the Organization Responsibility Working Group. Another is AI Control Working Group. Recently, with the help of the OWASP, I started the OWASP AI Vulnerability Scoring Security Scoring Project. We have a lot of people join from NIST, from CISA, from Entropic, from Scale AI, from Dropbox, uh, many. So this is an exciting project. We're trying to kind of measure the risk of the AI agents. I also teach a video course for the EC console. I'm leading the distributed apps.ai, which is a boutique consulting firm. With that, I would like to tell a little bit about some of the project. It's not all, but some of the project we did was in the OWASP. One is the agent naming service, which is really a protocol agnostic protocol, right? It's you can discover A2A agent, ACP, and a Web3 protocol agent using this naming service. And it use a PKI certification integration that can be a distributed PKI, not has to be like a centralized PKI. And you do have the verifiable agent identity, and especially you need to build a trust framework. I think that's very important. That's really to the key of the NADA and the advanced AI security spirit. Build the community, build a decentralized autonomous organization around it. And then you have to have a secure communication, right? Um, yeah, discovery also can be a dis decentralized. The we have this paper published, it is archived, but we get lots of press coverage. The registry in forward, and if you do the Google search of agent naming service, that will be the top in the list. The core architecture of this framework is first we have the kind of certificate authority that's can be decentralized certificate authority or centralized or federated. We actually discuss different deployment scenarios, and we do have the agent registry which store the agent capability. And then the registration authority, which I think the best way to actually implement it, we're also discussing the paper, is decentralized, right? Through the community to drive this and to verify agent request and manage the life cycle of the agent. And then each different protocol can have a naming or index in with NADA, right? NADA index in this naming service. And then you can have extension through the protocol extension or adapter layer. And yeah, so how do you register? You submit the request and some validation happen, and then certificate is issued, and then you have the registration storage. This is basically the structure for the naming structure. And the resolution is really you pass the naming that we provided before, and then you do the lookup, and then you have to validate. Uh, because there's different version, you have to make sure which version you are talking with, right? So there's a version negotiation. Eventually, you return the endpoint, which includes the metadata for the agent. And then, of course, you have A2A adapter or ACP adapter. MCP mostly is the agent to tool communication, but you can wrap it as a MCP agent if you like. So that it could be negotiation and also the adaptation as well. Um, yeah, of course, we use the framework, which is called the Maestro Agentic AI Threat Modeling Framework that we developed within Cloud Security Alliance, and also with the collaboration with OWASP as well. And we use that to do the analysis uh, for some of the vulnerability that we need to be careful. So we do have a protocol open source, has the if you go to this GitHub, there is already the MVP built, and we have the video to discuss how we go through it. Um, I will not click it. If you're interested, I will share the slide. You can take a look. And most importantly, how we integrate with the NANDA, right? So, especially with the security, there is potential phishing and agent impersonation attacks, capability misrepresentations, endpoint spoofing, and privacy leak, right? How we deal with it? We build a security blueprint, and we also publish a paper soon. It's still under review. I think in about 3 weeks or so time, it should be published. So the idea is we have the dual trust anchors. It's basically you have the initial lookup, and then you can privacy preserving kind of query, um, and you have the least trust registry call. This is very important. It's also for performance reason, and hopefully we can build a trustless uh, protocol for that, right? So with same spirit as the Web3. Um, we do the Maestro framework, kind of threat modeling, and also traditional strata threat modeling, and see what kind of threat could be and what could be the mitigation. And here's the reference architecture component, right? So NADA has a hybrid root, and then agent has the factor store using the JSON LD, and ANS, of course, the certificate follow the standard, but with the uh, some of the extension for the capability discovery. We do publish a capability discovery and a negotiation protocol in archive. I shared today at the LinkedIn post. You can take a look. Um, yeah, I also put some of the GitHub for that uh, uh, architecture as well. So here's the um, demo that we can go through a little bit for the discovery. You can like go through a one of the agent, and that's the summary it has. That's the detail, like you can find what kind of capability it is and what is its endpoint and the attestation basically to attest that it's right. Then you have the protocol extension. So this is some of the main capability it should have, and you can also register the new agent with called it as NADA Agent One, because the NADA agent is already registered, then it will give you the ID and unnecessary information, then you can register. So in summary, I just talk about one work that OWASP work with NADA, and I think myself also individually working with NADA team as well. So what we see is the current AI agent system has security holes. We will publish also soon through the AI vulnerability scoring system project to try to measure agent risk scores, and then we can build around it in the registry as well, and then how we can trust it, right? So you do need a security blueprint with NADA plus ANS. That's a really a very good combination. And in terms of discovery, NANDA has a two-hop discovery. It's very important for both performance and the privacy. The first hop is lightweight and fast, and the second hop really depends on the kind of consent, right, and also the privacy-preserving technology. And then we have to use a security-centric design with privacy-preserving discovery and cryptographic security guarantee. That's all I have. Thank you, and have a very good conference, yeah, and workshop. Thanks, everyone.